Article 505 of the National Electrical Code, or NEC, addresses the specific use of flexible cords and cables installed within a raceway. A raceway, for clarity, encompasses conduits, electrical boxes, and other approved enclosures designed to protect and route electrical wiring. To understand Article 505, it's important to compare and contrast it with Articles 500 through 504 of the NEC. Generally, Articles 500 through 504 mandate overcurrent protection for flexible cords and cables. This requirement stems from the inherent vulnerability of flexible cords and cables to physical damage, increasing the risk of overloading and subsequent fire hazards. Overcurrent protection devices, such as circuit breakers or fuses, are typically employed to mitigate these risks by interrupting the electrical circuit when excessive current flow is detected. Article 505 presents an exception to this general rule, permitting the installation of flexible cords and cables within a raceway without the need for supplemental overcurrent protection, provided that specific conditions are satisfied. These conditions are critical for ensuring safety and proper functionality. Firstly, the raceway employed must be explicitly approved for the intended application. This typically includes rigid metal conduit, electrical metallic tubing, or appropriately rated electrical boxes. The selection of the raceway type should be based on the environmental conditions and the anticipated mechanical stresses to which the installation will be subjected. Secondly, the flexible cord or cable must be securely fastened within the raceway. Proper securing techniques prevent strain on the conductors and terminations, reducing the likelihood of damage or disconnections. Thirdly, the raceway must be located in an accessible area, facilitating inspection, maintenance, and servicing. Accessibility ensures that any potential issues can be identified and addressed promptly, minimizing downtime and maintaining safety. In essence, Article 505 offers a more relaxed approach than Articles 500 through 504 with respect to overcurrent protection. However, it's crucial to recognize that this relaxation is contingent upon strict adherence to the stipulated conditions. By fulfilling these requirements, the risk of electrical hazards is adequately managed, allowing for the safe and efficient use of flexible cords and cables within raceway systems. Article 505 is not restricted to any specific type of application, such as industrial settings. Its provisions can be applied across a broad spectrum of installations, encompassing residential, commercial, and industrial environments. The applicability of Article 505 hinges solely on whether the conditions for its use are met, regardless of the type of facility. Now let's elaborate on each of the conditions in detail, so the code can be properly followed. When selecting a raceway for use with Article 505, several factors must be considered. The raceway should provide adequate physical protection for the flexible cord or cable, shielding it from potential damage caused by impact, abrasion, or environmental factors. The raceway should also be sized appropriately to accommodate the conductors and any necessary fittings while facilitating proper heat dissipation. Furthermore, the raceway material should be compatible with the surrounding environment, resisting corrosion or degradation from moisture, chemicals, or extreme temperatures. Common raceway types include rigid metal conduit, intermediate metal conduit, electrical metallic tubing, and flexible metal conduit. Each type offers varying levels of protection and flexibility, allowing for customization based on the specific application requirements. When securing the flexible cord or cable within the raceway, appropriate fittings and connectors should be used to ensure a reliable and strain-relieved connection. These fittings should be designed to prevent the cord or cable from being pulled, twisted, or damaged during normal operation or maintenance. The securing method should also comply with the relevant installation standards and manufacturer's instructions. Proper securing techniques not only enhance safety, but also prolong the lifespan of the electrical system. Accessibility of the raceway is paramount for routine inspections and maintenance. The raceway should be located in an area where it can be easily reached without the need for specialized tools or equipment. Obstructions should be minimized to allow for clear visibility and unobstructed access to all components. Adequate lighting should also be provided to facilitate visual inspections. Accessibility ensures that any potential problems, such as loose connections, damaged conductors, or water ingress can be promptly identified and rectified, preventing more serious consequences. Now, let's delve into the specific differences between Article 505 and Articles 500 through 504. Articles 500 through 504 primarily address hazardous locations, which are areas where flammable gases, vapors, dust, or fibers may be present in sufficient quantities to create a fire or explosion hazard. In these environments, electrical equipment must be specifically designed and installed to minimize the risk of ignition. Articles 500 through 504 impose stringent requirements for overcurrent protection, grounding, bonding, and sealing to prevent the propagation of explosions or fires. Article 505, on the other hand, is not limited to hazardous locations. It applies to general-purpose applications where flexible cords and cables are installed in raceways for mechanical protection and convenience. While overcurrent protection is still a concern, Article 505 allows for some flexibility in its implementation, provided that aforementioned conditions are met. In situations where Article 505 is deemed applicable, it's essential to conduct a thorough risk assessment to determine the adequacy of the existing overcurrent protection. Factors to consider include the ampacity of the flexible cord or cable, the rating of the upstream overcurrent device, and the potential for overloading or short circuits. If the risk assessment indicates that additional overcurrent protection is necessary, supplemental devices such as fuses or circuit breakers should be installed in accordance with the NEC. It's important to note that Article 505 does not supersede or override any other applicable requirements of the NEC. All electrical installations must comply with the code in its entirety, ensuring that all safety measures are properly implemented and maintained. Now, let's explore some practical examples of how Article 505 can be applied in real-world scenarios. In a residential setting, Article 505 might be used to install flexible cords for lighting fixtures in a basement or attic. By running the cords through a rigid metal conduit, the cords are protected from physical damage and moisture, while eliminating the need for additional overcurrent protection. In a commercial building, Article 505 could be used to route flexible cables for powering equipment in a retail store or office. The cables can be installed in electrical metallic tubing, providing a neat and organized appearance, while also ensuring safety. In an industrial facility, Article 505 might be used to connect portable machinery or equipment to a power source. The flexible cords can be run through flexible metal conduit, allowing for easy movement and reconfiguration of the equipment, while still maintaining compliance with the NEC. In each of these examples, it's crucial to verify that the specific conditions of Article 505 are met before proceeding with the installation. This includes selecting the appropriate raceway type, securing the cords or cables properly, and ensuring accessibility for inspections and maintenance. It's also important to consult with a qualified electrical contractor or engineer to ensure that the installation complies with all applicable codes and standards. Now, let's address some common misconceptions about Article 505. One common misconception is that Article 505 is a loophole that allows for the circumvention of overcurrent protection requirements. This is not the case. Article 505 provides a specific exception to the general rule, but it's contingent upon strict adherence to the stipulated conditions. Another misconception is that Article 505 is only applicable in certain types of facilities. As mentioned earlier, Article 505 can be used in residential, commercial, and industrial settings as long as the conditions for its use are met. It's also important to note that Article 505 does not apply to all types of flexible cords and cables. Certain types of cords and cables may have specific limitations or restrictions depending on their construction and intended application. These limitations should be carefully considered before using Article 505. Finally, it's crucial to remember that electrical codes and standards are constantly evolving. The NEC is updated every 3 years to reflect advancements in technology and changes in industry practices. It's essential to stay informed about the latest revisions to the code and to consult with qualified professionals to ensure that all electrical installations are up to date and compliant. The NEC serves as a comprehensive guide for safe and reliable electrical installations. Its provisions are based on years of research, testing, and practical experience. By understanding and adhering to the NEC, electrical professionals can help prevent electrical hazards and protect lives and property. In conclusion, Article 505 of the National Electrical Code provides a valuable exception to the general rule of overcurrent protection for flexible cords and cables in raceways. By carefully considering the conditions for its use and complying with all applicable codes and standards, electrical professionals can safely and efficiently utilize Article 505 in a wide range of applications.